Okay, so let's do another example here. So we're given this function here, g at x is equal to x squared times e to the power of 5x cubed. And then we're asked to find the integral from the interval of a to b of g at x dx, where a is equal to the cubed root of ln 15 over 5, and b is equal to the cubed root of ln 45 over 5. So how would we go ahead and evaluate this integral here? So let's start by first defining some placeholders. So in a previous example up here, we called our placeholder t. In this example, it's called something else. Let's just call it box, like we've been calling our placeholders before. So let's call it 5x cubed. And then the derivative of that, the derivative of the box with respect to x, is equal to 15x squared. Okay, so what that means is if x, okay, is equal to a, okay, if x is equal to a, this a right here, which is equal to the cubed root of ln 15 over 5, then our box, okay, is equal to, okay, 5 times that cubed. So this box here, then the box is going to be equal to 5 times x cubed. Okay, and since this is x, this would be the cubed root of ln 15 over 5. And I meant to say squared, not, or I meant to say cubed, not squared. So 5x cubed, so it'll be 5 times x cubed. And what we get from that is just the cubes cancel out, the cubic root and the cube cancel out, and then the 5 and the 5 cancel out, so we just get ln 15. And then if x is equal to our other interval here, b, that gives us the cubed root of ln 45 over 5. Then this box is going to equal, like here, our placeholder is going to equal 5 times the cubed root of ln 45 over 5 cubed, which is just going to equal ln 45, like so. So now we can go ahead and start evaluating our integral. Now that we have our placeholders, and then we have our intervals all set up. Okay, we have it all set up like so. So let's go ahead and do that. So what the question is asking for is the integral from a to b, which is, this is a here and this is b, of x squared times e to the 5x cubed dx. Okay, and so we can start substituting. Okay, we can start performing integration by substitution. So another way we can write it is, I'm going to leave the intervals out for now. X squared times e to r to the box dx. Okay, because our box is 5x cubed, so e to the 5x cubed dx. But as you can see here, we have x squared dx here. Okay, so we can write this as, if we rearrange the way this looked, it would look like this: e to the box times x squared dx. And remember, we want to put this in terms of this placeholder here. So what is x dx? Okay, what is this, right, in terms of our box? Well, if we look up here, okay, we can rearrange our equation to make it look like x dx. So if we did that, okay, so if we divided both sides by 15. Okay, so if we brought the 15 down here and brought the dx up here, we would get this. D box by, I'll put it this way here, x dx is equal to, or x squared dx I should say, okay, 15 divided by, or sorry, not 15, d box divided by 15. Okay, because all we did was just a rearrangement to manipulate it to get an expression that equals x squared dx. And another way we can write this is 1 over 15 times d box here, like that. So when we come back to our integral here, we can substitute that. Okay, you can substitute this into here. You can substitute that in there, and then we would get this. We get this. We get e to the power of our box times 1 over 15 d box. So now it is in a good form to integrate, and of course what we can do too is we can take out this 1 over 15, we can take it out of the integrand, 1 over 15 times the integral, yes, of e to the box d box. And of course what we can do now is we can actually put in our intervals here. Okay, so previously we had a, now we have, which was this, now we have a ln 15, so we can put ln 15 down here. And then b up here, b was this expression here, it's now ln 45. Okay, and we substitute our values back in, we get 1 over 15. We do the integral from ln 15 to ln 45 of e to the 5x cubed d box. Actually, you know what I'm going to do is I'm going to keep the 5x cubed out. I'm just going to leave it as is. Okay, we don't need to write all that. Okay, so we can now actually integrate it. And as you know, the integral of an Euler function is just itself. Okay, so what we would get is, we'd get this, we would just go ahead and integrate it. We get 1 over 15 times e, okay, times e to the times e to the to our box here from the interval of ln 15 to ln 45, which would give us this 1 over 15 times e to the power of ln 45 minus e to the power of ln 15. When we simplify that, we get this. Okay, so e to the power of ln 45 is just going to be 45 minus e to the power of ln 15 is just going to be 15. And of course 45 minus 15 is 30, so we get 1 over 15 times 30, and 30 over 15 is 2. And that would be our answer there.